No, but what is it? They don't eat anything.
Check 8. Awesome, awesome. Okay, so let's get started then. Oh wait, no, I gotta get a drink.
Yeah, it's good. Because it was there we go.
Delicious. Every time. Okay, we all did number 1 in class. So we're going to look at number 2. You want to compute a 90% confidence interval for a mean with a population, with an unknown population standard deviation, sample size is 30. Which t-star should we use? Well, we need, n was 30, right? And confidence was 90. Erase. All right, so the confidence level is 0.90. And so T star 29 should be equal to, just right out of the calculator, anyone? 1.699. 1.699. Again, that's right out of the calculator. There really isn't a whole lot to do there. All right, question 3.
We did, right. Period 3.
Yeah, we did.
Yeah, we're going to do it again. So we have a laboratory scale. Still get periods, the work over here. And we want the margin of error to be less than 0.0001. We have the standard deviation given as 0.01. And so this is the margin of error formula. So the margin of error formula needs to be less than 0.0001. Plug in all the variables for z star, sigma, and of course square root of n is unknown. You get this equation. Just a little bit of rearranging, and you get this. Square root of n has to be greater than this expression. This expression solved out is 196. And after you square both sides, we get that n should be greater than 38,416, which is a lot of measuring. Like if you did one measurement every second, that'd take 38,416 seconds. How many minutes is that?
38,416.
38,416. It's 100 minutes. 100 hours.
640 minutes and divided by 60.
You got 106 hours. You got how much?
Yeah, it's 10 hours.
Why don't you subtract that?
Oh, you know what? I got 10 hours too.
Yeah.
Place value. Sorry. 10 hours of measurement straight. Okay. The next part of that question is, now we want the width to be less than 0.0003. So I drew kind of a picture here of what that width looks like. The interval width is made up of the left and the right side. So we're looking at two margins of errors. You have a margin of error on the left and a margin of error on the right. And the two margin of errors together are 0.0003, which means that a single margin of error should be 0.00015. Doing the same process of solving, you get that n should be greater than 17,073.7. Interval width? Is Miss Brunel's door closed?
She just.
Okay. Okay, so which means that since we have to be bigger than this, that means 17,074 would be our sample size.
This classroom feels empty, but it's not.
Hmm?
I said this classroom feels empty, but it's not.
Yeah, that's a lot of people, actually.
Yeah, but it does feel.
Are we good?
Yeah.
Okay. I'm going to copy and paste this over. See if I can manage to do this. Awesome. Cut. And paste. 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 Let's move 15 down. Thinking my plan here is not that great of a plan. Yeah, my plan is not that great. Yeah, that's a horrible plan. All right, that's better. All right, 3. Here, let's do question 4. All right, so question 4, we have the weights of 9 men have a mean of 175 and a standard deviation of 15. They were polite enough to give it as an S, so that tells me we need a Z interval. Okay, so what do we have for number 4? We say n equals 9. We have x bar equals 175, which we don't need. And we have S equal to 15. Standard error is equal to S divided by the square root of n, which would be 15 divided by square root of 9, or just 5. Okay. Sorry. Okay. Question 5. This is our confidence interval. And what I'd like to do is I like to picture this on a number line. So what would this look like on a number line? Well, if I was on a number line, I would see this point right here. We would call that 44.2. And this point right here, we would call that 54.2. Okay. So that's my left bound and my right bound. What number would be right in the middle? 49.2? 49.2. Believe it or not, that's the spot measurement. That's the X bar part. So actually, X bar is always the exact middle of the confidence interval. Now that you know what X bar is, you should be able to calculate the margin of error. This is a margin of error here. That's the margin of error here. So it looks like 5.
Yeah.
Is there a unit to this? Yes. For question 5, the margin error is 5. Yeah, I think it is. No? Can you say that with 90% confidence?
I'll go 88.
88. 6. The level of diluted oxygen in a river is an important indicator of the water. That's all sorts of stuff that I don't really need to know, right?
Yeah.
I'm collecting 20 milliliter samples. Again, I don't need to know how big the samples are. At 15 randomly chosen locations, and we measure the diluted oxygen. Here are the results. Check the assumptions for the T interval. Construct and interpret a 95% T interval. Okay, well, we'll need this in our calculator. Okay, let's clear all 3 of those lists. Okay, clear. Mem, what happened just now? Clear all lists. That's a pretty handy one right there. Clear all lists. I'm glad we found that. Where did we find that? Period 3? I don't know. Stat. Let's put these numbers in. 453. Why am I not using my keyboard? 4.53, 504, 329, 523, 413, 55, 483, 44, 542, 638, 401, 466, 287. Wow. What happened there? 573, 555. Great. Okay, so we have all of this in list 1. Let's screenshot this, put it in our notes. There's our screenshot. The next one I want to look at, oh, well, no, before we even do that, we need to do the rest of this. So we need the parameter. Mu is the mean amount of oxygen dissolved in the river. Oh, I'm sorry, it's a stream.
Just say body of water.
the correct grammar when we write these, or can we write shorthand? It's acceptable?
Yeah. The mean amount of oxygen in the sample of 15 locations. Okay.
Wait, would it be mean amount of oxygen dissolved?
Yeah. Yes.
Wouldn't the, in the mu, wouldn't that be the river, and the stream would be the export?
No.
Oh, yeah, I think they're the same thing here. I think that they're using stream and river as synonyms.
Interchangeably.
Interchangeably, thank you, that's the word. Interchangeably. Would you call the LA River a stream or a river?
I call it man-made.
Well, actually,
I call it man-made.
It's not man-made.
No, it depends if it's raining.
Well, yeah, it's true. Depends if it's raining.
No, there used to be more people dying from floods from the LA River than earthquakes.
Really?
Yeah.
Or on the
And so in order to control the floods, they concreted over the LA River. Yeah.
well, because now, I guess since they concrete, it looks pretty nice.
probably gonna be full after this weekend.
So,
Yeah.
so ask us on Monday.
Ask you how you feel on Monday. Okay, that's our parameter, our assumptions, which are really conditions. Okay. Okay, so do we believe that this is an SRS?
Yes. It says random, so.
Okay, so we are told this is a random sample.
Just as this is a random sample and it doesn't say this is an SRS, does that class, like, should you not say it's an SRS?
Well, I'm sorry.
If the problem, it doesn't say it's an SRS, it just says a random sample was taken. 15.
You would probably write down that you were told that this is a random sample, so we're going to assume it's an SRS. We're going to assume that they mean SRS. Right, independence. Okay, so this is kind of a weird one for independence because we're picking up the dissolved oxygen in 15 locations. So there need to be more than 10 times 15 locations in the stream.
Well, it depends on what you define as a location in the stream.
Yeah, so it's a little weird, right? So depending on the definition of location, there are likely more than 10 times 15, which equals 150. Along the stream. More likely than not, there's going to be more than 150 locations. You have no way of knowing that for sure, but this seems pretty likely, right?
Well, if we just randomly, every step is a different location, randomly scroll down.
That's the thing, you don't know how big each location is. If the top of the stream only has, 100 square feet, and each location is 10 square feet, then you're cutting it close. So it all depends on what's defined as a location by these scientists. Now for the normality. This is the big problem. Let's take a look at our plots. First plot. Let's take a look at the how do you call that? Box plot. Zoom 9.
Why does it say put,
Why does it say what? Make sure you put it in the correct list.
yeah,
Because we were playing
Yeah.
around. We were playing around with list 3 during class today.
because we were doing the double.
Yeah.
Every time I push the Zoom 9 from the stat plot menu,
Mm-hmm. There is a programming glitch that sometimes you get weird soft menus. Yeah. Mm-hmm. Just quit to the home screen and then push Zoom again.
It looks like we're clear outlines.
This looks pretty good.
It's not clearly not. That's when clearly not.
Well, here, I mean, don't worry about symmetric or not. This looks pretty symmetric to me, but the real reason we're looking here is for outliers. So no outliers. Okay, so let's see, screenshot. Okay, so screenshot number 1, no outliers. Do not appear to be outliers. Next one, histogram. And then zoom 9 again. Oh. Can't ask for anything better than that, really.
Yeah, around. It's a little bit better, but
Can't ask for anything better than that. Well, a little better.
exactly.
Okay.
Pretty symmetric.
Yeah. Okay, histogram is single peak symmetric. Put the word approximately there,
Just to be clear.
just to be safe. Because, you know, that isn't exactly single peak symmetric.
So always put a prox just to
Approximately, you don't want to get hung by your own words.
fit that
Lastly,
those single words can be real killers.
yeah, the normal probability plot.
It's okay.
Yeah, that's not bad.
It's not bad.
Approximately.
That's approximately linear. It's at least as linear as we need it to be, right? Okay, and lastly, normal probability plot is approximately linear. Okay. Our evidence suggests that the sampling distribution, remember I made a big stink about this, always link to the sampling distribution, is approximately normal. Right, so we're pretty good. This is a one sample t interval for a mean, for a meanie. For a blue meanie.
What?
You don't know the blue meanies, do you? Do you remember there was a Beatles movie called, it was animated, it was called The Yellow Submarine?
Yeah.
Yes. And the bad guys were blue and they were called blue meanies? Yeah, those are the blue meanies. All right, so now we can go ahead and calculate things. Let's go to the home screen. Stat, calculate one var stats for list 1. There we go. Everything we need is that first screen. Okay, so the only thing that we need now is the T star 14, right? What was our confidence level again? 95? So T star, I heard someone say it, what is it? 1.5?
145.
145. 145. Three decimal places.
What was it? What was the mean though?
X bar is 4.77. All of our data is to 2 decimal places, so I think we're okay if we put our mean to 2 decimal places as well. Okay. So 4.7.
Kinda all plays out
Yeah.
the same.
T-star is always 3 decimal places?
T-star is always 3 decimal places. We're going to be doing T-stars and Z-stars a lot. They are always 3 decimal places.
But then normally final answers around 2.
Final answer really depends on the data.
Okay.
Looking at the data we have here, this is all to the 100th place. So we want to keep it to around the 100th place. All right, so our confidence interval is equal to x bar. What was x bar? 477?
Yeah.
Plus or minus 2.145 times the standard deviation, which looks like 0.9396, divided by the square root of 15. And let me know when you get a margin of error.
0.520. Well, how many decimal places would you want for margin of error?
One more decimal.
0.01.
5201.
Yeah.
520. Uh, 4.25
Yeah.
to 5.29.
Yes.
So we are 95% confident that the what is that? The mean
But the average.
amount, thank you, amount of oxygen dissolved in the stream is between 4.25 milligrams per liter, thank you, milligrams per liter, and 5.29 milligrams per liter. Were there any assumptions that did not hold true?
The interval, I mean the
Independence?
independence.
Okay. No. Don't forget the units.
Wait, no, you won't. Obviously, don't forget them.
Yeah.
Or you know you'll mark.
You won't get marked down if you forget. Just don't forget.
Just put it.
Yeah, it's not that hard.
Units are important. I'm sure every science teacher has told you this
Yes.
since you were in like 6th grade.
That unit is just a number.
Yeah.
What does it mean?
Death would
Yeah, we need to check the independence condition. Namely, there needs to be more than 150 test locations along the stream. Okay, that's being really picky about this. Most of the time we would just kind of assume that there would be more than 150. But it's true. This needs to be true.
Either way, we have to finish the problem.
Hmm?
So
Either way, you have to finish the problem. Is there anything else here? Gosh, I hope we don't have to do a whole lot more of these.
You made
You
this.
wrote it, so you should know that.
Check this?
Next
think-
time, when you make the test, keep that in mind. How many of these you'll have to grade.
That's true. A polling organization announces the proportion of American voters in favor of congressional terms is 64%, with a 95% margin of error of 3%. This means that this is a multiple choice.
Oh,
Does this mean that if the poll were conducted again the same way, there's a 95% chance that the fraction of voters favoring voting limits would still be between 61 and 67%? No. A. What are we saying about A? Confidence level is about repeated samples. Okay. The parameter is either in the interval or not. And I don't know where they get, 61 and 67, yeah. Okay, most likely you would get an interval that is not 61 to 67, most likely. If there's a 95% there's a 95% probability that the true percentage of voters are within 61 or between 61 and 67%. No. Okay. The true parameter, or the value of the parameter, is either in the interval or not. There is no probability. C. If this poll were conducted again the same way, there's a 95% probability that the percentage of voters favoring term limits in the second poll would be within 3% of the percentage favoring term limits in the first poll.
This still has probability.
No. No. Confidence level is not about probability. It's not, well, the probability of the parameter being in the interval. D. Among 95% of, no, that's just wrong. That's just wrong. So it looks like none of the above.
So what would it be?
None of the
No, I'm saying like if a right answer was there.
Yeah. If this procedure was repeated multiple times, okay, 95% of the confidence intervals created would contain the value of the parameter. Okay. Our one sample is either part of the 95% or part of the 5%. We don't know which one it is. Okay. We're more likely to be part of the 95% than we are being the 5%. So we are more likely to have the value of the parameter in our interval than we are not to have the value of the parameter in our interval. Eight. 7 was E, right?
Mm-hmm.
Ocho. A random sample of 900 individuals is selected from a large population. I assume they mean more than 9,000. 180 are regular users of vitamins. Thus, the proportion of regular users of vitamins in the population is estimated to be 0.20. Just so that you know, 0.20 is equal to 0.20. Yeah, thank you. Is equal to 180 over 100. 180 over 900. What is the standard error? Okay, so we're looking at standard error for proportions. What is standard error for proportions? Standard error for proportions is, yes, p hat times q hat divided by n, the square root of the entire thingamajigger.
Entire thingamajigger?
The entire thingamajigger.
Sure.
So that's equal to the square root of 0.20 times 0.80 divided by 900. Very nice. Standard error is equal to
0.013.
excellent.
Answer that.
9. 95.
Same difference.
9. How long have we been recording, by the way?
Probably 40 minutes.
Yeah, 40 minutes. Okay. So maybe a couple more problems and then we'll take a break. Oh, we should just take a break. Do this problem, then we'll take a break because then we'll be halfway-ish. No, we'll be a little more than halfway. But I have a feeling the last few problems are really heavy.
Yeah.
Maybe we should do a couple. Okay, 95% confidence interval for P, the proportion of Canadian beer drinkers, A, who prefer Red Lion, A, was found to be 0.236 to 0.282. Interpret the interval in context. Okay, so that's cool. Number 9, A. We are 95%, 90? 95%. Oh, maybe we should do it this way. If the sample was conducted many times, 95% of the samples would contain the true proportion of Canadian beer drinkers, that's all of them, who prefer Red Lion. Sorry, Lion Red. Lion Red. Red Lion is a German eatery in Silver Lake. I may have been there.
May have, you know.
They may have an awesome happy hour. I don't know. Bratwurst and sauerkraut for everybody.
So that sounds pretty good. Sauerkraut is live.
Would these also be acceptable for notification? We're 95% confident that the proportion of Canadian beer drinkers who
Yes.
prefer Red Lion between 2-3
Yeah, that would be the way that we would normally summarize. But I have a feeling that this one, the real context here, is we want to actually get behind what does it mean to be 95% confident. Yeah.
When it says 0.236 and 0.282, should we round it?
No. Here's another thing to think about: the confidence interval, the interpretation of the interpretation of confidence interval has nothing to do with the actual interval. It's all theoretical based on that 95%. It doesn't matter what the interval is. That 95% confidence interval means that You could be part of the 95%, or you could be part of the 5%. You don't know. Okay? How did they say it in this? We are reasonably certain that the true proportion is between. Wow, that's not helpful at all.
No, I don't think there are any typos on this one.
Really? Fascinating.
So if we,
Fascinating.
number 9, if we state it as if, like, the conclusion, that's
This would be part of a multiple choice question.
So it wouldn't be anything like that similar.
Okay, we can eat up number 10 really quickly.
easy. You just put it in conversion on it.
Yeah.
Oh,
Or you
Z star 70.
What are they doing?
Let's see. Maybe I should draw this. That might help a little bit too. I like my drawings. Something's wrong with Ryan Beatty.
Yeah, I was about to say, what are they doing over there?
What happened to Ryan Beatty?
Fans.
He's not even here yet?
It hasn't gone on yet.
Hasn't gone on.
it's 4:30.
It starts at 4:30, so unless he starts right now, but nothing could have happened before.
We don't know that. He could have some serious.
No,
He could have some really crazy things.
All right, so that's 70% there. That means the tails are 15%. So if you're using your calculator the traditional way,
I like yours.
the traditional way, yes, we would do an inverse norm of the tail, which is 0.15.
You put so much energy into this.
Giving us a z-star of 1.036. Screenshot. So z-star equals I forgot the number. Thank you, thank you. 1.036. Okay, then I think we should break for a few minutes here.